Okay, guys, good morning. Um, I am, of course, recording this Sunday evening because that's a little easier for me to do right now. Um, okay, so we're going over chapter 4. Last week we studied chapter 3, which was over rational numbers, integers, which have a negative and a positive. Let's actually go back a little bit. Let's go over our focus, our review of chapter 3. You guys can get out your review. Chapter 3 summary. Keywords. Numbers greater than 0 are called positive numbers. Numbers less than 0 are called negative. Negative have a minus sign right before them. So they have like a negative 3. Okay. A positive 3 it can have a positive, or if you're adding it, it'll be a positive unless you're adding a negative, but that's different. Um, they're going to have a positive. Now, opposite numbers. Every number other than 0 has an opposite. The opposite of positive 8 is negative 8. The opposite of negative 2 is positive 2, or just 2. You don't want to include the positive. Okay, absolute value of a number are these bars right here. And all that means is negative 9 is 9 spaces from 0. Positive 9 is 9 spaces from 0. I hope you guys remember a little bit of this because we studied this past year. Okay, a rational number is a number that can be written in the form a over b. And when a and b are integers, b will not be 0 because you can't divide a number up into 0. But if you were to do 1 divided by 2, you would get 0.5 as your answer, and that would be a rational number. It's called a terminating decimal. All it goes to is 5. Now, if you had 7 over 1, that's just 7, and 7 is a rational number. Now, trying to think. If a number is divided, so say you take 7 divided by 22. That actually is a repeat. Nah. Yeah, it's basically repeating, so that's not what I'm looking for. 7 over 3 would be, or 22 divided by 7 would be a rational number. 23 divided by 7 is not a rational number because it goes off forever. So 23 divided by 7 is an irrational number because it doesn't repeat itself, and it does not have it does not terminate, just goes on forever. So essential rules and properties. Order relationship. A is greater than B if A is more than B. So that's further to the right. So say like you have this one, you have negative 6 is greater than negative 12. That is because negative 6 is farther to the right. It's not as negative as 12. To add integers with the same sign. I'm really not as concerned about this, but if you were to add 6 plus 4, you would get 10. If you wanted to add a negative 4, you could do 6 plus negative 4 equals negative 10. Um, and that you would just enter into your calculator. To add integers with different signs, you would do -6 plus 4. That would be -2. Now, if you took 6 plus -4, you could just do 6 minus 4 if you wanted to, but you guys are using calculators, so don't sweat this. Okay? And I encourage you guys to seek out understanding of it. But for right now, just concentrate on using your calculator. Okay, so to subtract two integers, 6 minus 4, you do 6 plus -4. I think that's a waste of time. Just do the 6 minus 4. You don't have to do 6 plus -4. It's the same thing. Okay, to multiply integers with the same sign. So if you have 3 times 5 equals 15. If you have -3 times -5, then you still get 15, just as long as the signs are the same. Now, if the signs are different, it's always going to be negative. I don't care which number is the negative number, they'll both be negative. To divide two integers, when you divide them, if one is negative, the answer will be a negative. If both are negative, the answer will be a positive. If they both are positive, the answer will be positive. Okay, now we're going to go properties of addition. You have the addition property of 0. If you add 0 to a number, unless the number is 0, it's not going to be 0, but it will be whatever number you're adding 0 to. So if I have $5 and I add 0 more dollars to it, I will have $5 still. Now, the commutative property says if I have a number a plus b, well, it's going to equal the same as b plus a. You can switch those around. You can do that in multiplication too. Can't do that in division and subtraction, but you can in multiplication and division, or multiplication and addition. Okay, so the associative property of addition is just when you're moving um, the parentheses. So instead of going a plus, or no, wait, property, instead of going um, a plus b plus c, you can go a plus b plus c. Okay, so the inverse property of addition. You can take a plus negative a equals 0. Or you could do negative a plus a equals 0. I don't really care for that much because it's not going to apply a whole lot. I've never had to use it. I've had to teach it, but never really use it. Okay, the multiplication property. A times 0 is always going to be 0. Any number, if you have it 0 times, will be 0. Okay, so multiplication property of 1. Any number times 1 is always going to be the number you're timesing by 1. If I have 1 million times 1, I'm still going to have 1 million. Okay, commutative property of multiplication means a times b equals b times a. It's just like addition. And by the way, guys, I was in high school studying this, so you guys are doing awesome. The associative property of multiplication is a times b times c equals a times b times c. It's the um, same idea. So, division property of 0 and 1. Okay, so if you if you take 0 divided by a equals 0. So you can 0 can be divided by, and it's always going to be 0. If you try to divide a number by 0, it's always going to be undefined, or your calculator will say error because you can't divide a number up into 0 pieces. Okay, so a divided by 1 is always a. So if we want to make a number into a fraction, we just put it over 1, because this number here divided by 1 will always equal the top number. Okay. The order of operations. Remember, do parentheses, that's please. Then do exponents, which is excuse, please excuse. Then you do multiplication and division. You do them from left to right. And that is my dear aunt, or my dear. And then you do addition and multiplication and subtraction, which is Aunt Sally. So please excuse my dear Aunt Sally. Okay, so now we're doing the reviews. I want you guys to be working on this yourself. Let's do number 9. Divide negative 51 divided by negative 3. Well, they're both negatives. So our answer is going to be a positive. So we just do negative 51 divided by negative 3 equals 17. So our answer for that one is 17. Easy peasy. Okay, so guys, we hopefully you guys did all of this, because that was your assignment to do this weekend. If you still need to work on it, continue to work on it. Now we're going on to chapter 4. This is for section 4.1. We're dealing with only one objective, and that is to evaluate a variable expression. Focus on success. Are you making attending class a priority? Yeah, hopefully you guys are. Your mom makes sure of that. Okay, so let's go down to prep for the test. Subtract negative 12 minus negative 15. So those both become pluses, but I don't care because you guys use your calculator. So you guys should be able to do all this. Just do negative 12 minus negative 15 equals 15.12. That shouldn't be correct. What did I mess up on? Oh, whoops, I put 0.12. Okay. Oh, I know what I did. I hit point instead of negative. Negative 12 minus negative 15 equals positive 3. All right, so I want you guys to do all of these. This is, again, show you guys how smart you're getting. And we've been whipping through this, guys, so fast. Now, this chapter 4.1, this is evaluating variable expressions. Okay, so you guys are closing in on, this is at least 6th grade to 7th grade level work. I am so proud of you guys. This is awesome. So, often we discuss a quantity without knowing its exact value. For example, the price of gold next month, the cost of new automobile next year, or the tuition costs for next semester. Recall that a letter of the alphabet can be called a variable, is used to stand for quantity that is unknown or can change or vary. An expression that contains one or more variables is called a variable expression. Okay, so that is where you'll see, like right here, I'm underlining it, x. X is often used as a variable. That's why we don't use it anymore for multiplication. We have the dot, or we have a number next to a parentheses, or we have the number next to a letter, because we don't want you saying, well, that's 3 times exponent 2. No, it's exponent 2, or x to the power of 2 times 3. Because technically you're supposed to square that x first. So we'll get onto that a little later, though. A variable expression is shown at the right. The expression can be rewritten by writing subtraction as the addition of the opposite. Like I said, guys, before, I'm really not worried about you changing minus 5 to plus -5. It's possible. It's just, to me, it's kind of excessive. It works when you're doing it by hand. It sometimes helps, and it helps you to understand what you're doing, but I don't find it to be that helpful. Note that the expression has 5 addends. The term of the variable expression are addend of the expression. The expression has 5 terms. Okay, so it's got all those. I don't think that's going to help you out a lot right now. It's just discussing this. The big thing to remember is a variable is an unknown or variable number. Okay, so now you have the term 3x squared minus 5y, 2xy, and negative or minus x are variable terms. So they're still discussing this problem up here. Each variable term is composed of a numerical coefficient and a variable part. The variable or variable and exponent. So you have the variables, you have exponents on them. We'll get into later on simplifying the variables too. But unless the variables are exactly the same, you cannot add or subtract them or group them. Variable expressions can be used to model scientific phenomenon, which physics lab a student might discover that weight of 1 pound will stretch a spring ½ inch. I'm not going to go into this too much because I think it'll get confusing. Okay, so now replacing each variable by its value and then simplifying the resulting numerical expression is called evaluating a variable expression. Now that we're starting to get onto the works, hopefully this will key in and everything that we've been discussing so far will um, work a little bit better for you. Okay, so the how-to one. It says replace each variable in the expression by its value. And right up here it tells us what the values are. A is 2 and B is -3. So we have AB minus B squared. So what that is saying is A is 2, so we go 2, and right here, we're looking at right here right now, 2, and we have the 2 next to the parentheses, which means you times it by what's in the parentheses. So it would be 2 times -3 minus -3 squared, or to the second power. So what we need to do first is we need to do what's inside the parentheses, which are just numbers right now. So let's start out with the first parentheses. 2 times -3. So we get -6. Then we're doing minus, and we take -3 to the second power. Remember, you can just hit -3 caret button 2, and your answer there will be 9. So your total answer will be -6 minus 9, which is kind of hard to see on this, but that is a -15. Okay, so we're going to go down to example 1. Name the variable terms of each expression. Name the variable terms. Well, the variable term is a squared. So we're doing it off of a. So we go 2a squared is our first variable expression minus 5a. 5 negative or minus 5a is our next one. We don't include the plus 7 because it doesn't have a variable with it. And we're only dealing with variables right now. So if we went over to the you try it, it would be 6n squared would be our first. Then we'd go 3n, and then we'd leave the 4 out because there's no variable associated with that one. So next one we will do evaluate x squared minus 3xy when x equals 3 and y equals -4. So we're going to do x equals 3. So we're going to do 3 squared, or 3 caret button 2 minus 3 times 3 times -4. So, okay, well, we do 3 squared, which is 9. Then we do minus 3 times 3, which would be 9 again, times -4, which would be minus 36. Oops. That would be -36 because you're timesing it by a -4. So it would be 9 minus -36, which would equal positive 45. So that's in essence how you would do this. And again, we've done this in the past. We're just going over it fully so you guys will understand. So next we go to example 3. Evaluate a squared minus b squared when a is 3 and b is negative 4. So we just go up at the top, a squared. Well, 3 caret button 3 is 9. Let's go minus b squared. What did b equal? B equaled negative 4. If you square negative 4, you get a positive 16. So then we're going to do the bottom. We're going to do 3 minus negative 4, so we go 3 minus negative 4. So we go equals 9 minus 16 equals negative 7 over, what did we have down here? A is 3, so you go 3 minus negative 4 should be over positive 7. And if you take negative 7 divided by positive 7, you get a negative 1. Okay? You guys can go back, redo that as many times as you want, rewatch this video, and use your calculators. Okay, so example number 4. That is evaluate x squared minus 3 times x plus or x minus y. Now you could distribute the 3 into both, but we're not going to worry about distributing right now. So we go x squared. What was x equal to? X is equal to 2. So we're just going to do 4 because that's x squared. 2 times 2 is 4. Then we're going to do minus 3 times x minus y. Well, x minus y would be 2 minus negative 1, which would be a plus 1. So it would be 3. This up here would be a 3, so we would go 3 times 3 is 9. So we would do 4 minus 9. Then we would do minus z squared. So z is 3. So this would be another minus 9. So you would take 4 minus 9, which would be negative 5. Then you would take minus 9 again, and that would bring it to a minus 9 again, which would bring it to a negative 14. Again, use your calculators. Basically what you would enter is this number right here with your calculator, because they've got all of our numbers. And what you would do is you would just enter the parentheses. And because it's got a bracket right here, there would be a parentheses, and then we'd have another parentheses inside the parentheses. Okay, concept check. I'll do a couple more of these with you guys. So we go 2x plus 5x minus 8. So what they want us to do is, for exercise 1 to 3, name the terms of the variable expressions. Then underline the constant terms. So I believe by constant terms, this would be a constant term, and 2x squared is our one variable expression, and 5 times x is our other variable expression. Must be windy outside. Here's some fireworks out there occasionally. Okay, so again, we're just figuring out what our variables are. I'm just going to circle our variable expressions and then underline the +7, which called a constant. Okay, 4 exercises 4 to 6. Name the variable terms of each of the expression, then underline the variable part of each term. Exercise expression. Then underline the variable part of each sentence. Variable terms. And then underline the variable part of each term. I probably skipped over this a little bit. It's just wanting us to realize that the variables. I'm not 100% concerned because as long as you guys know how to do the problems, usually we're not going to fuss over doing the variable, doing everything else. Okay, for exercise 7 to 9, name the coefficient of the variable terms. So we go x squared minus 9x plus 2. I think by that it wants us to do plus negative 9x. I do not want to bog you guys down with stuff like that because it's something that I have never used in my life. The variable expressions can be used to model scientific phenomena. We read that part. Historical. Today, X is used by most nations as the standard letter for single unknown hits. Adding the opposites. Adding the opposites. I believe that's what they're talking about. The terms a variable expression are add-ins. Each variable term. Numerical coefficient. So each variable term is composed of a numerical coefficient and a variable part. The variable or variables and their exponents. So when the numerical coefficient is 1 or an so what it wants by the numerical coefficient is it wants the numerical coefficient for this would be 9. Technically for this it would be 1 because you have 1x squared. You don't have to include the x squared. And the variable term is the x squared. And of course then you have the constant. I'm not really worried about that much, guys, because, if you learn how to do these problems, that's what's important. Okay, so 12 to 32, we got a whole bunch of these. We're going to evaluate the variable expression when a equals 2, b equals 3, and c equals -4. So I'm just going to rewrite a couple of these for you. So it goes 3a, so it's 3 times 2 plus, we're going to um, put these into parentheses because I want you to do 3 times 2 before you add 3 times b, 3 times, maybe 3 times 3. So what you would be doing, and if you put this into your calculator, you really don't have to worry about these parentheses. Just do 3 times 2 plus 3 times 3 because your calculator knows order of operations. I'm putting these here so that you can remind yourself. Actually, I'm not going to do that on the next one. So we go 2 minus 2c. Where is, c? C was -4. So what you do is you do 2 times -4. So, and that would be a -8. So what you would be doing is 2 minus a -8. Or you can change those negatives into pluses because you have 2 of them. And it winds up being 2 plus 8, or 2 minus -8, or 2 minus a -8. Okay, so 14, we go, we have a -a squared. What's a squared? A is 2. So what we're going to do is we're going to do 2 squared. 2 caret button 2, which would be 4. Then we drop the negative. Okay, so you guys continue on doing these. We get down to these, you're just plugging in the numbers again. B plus C. What's B? B is 4, C is -1. So we go, B is 4 plus -1. You could do 4 minus 1, but I'd prefer you enter things correctly into your calculator. So 4 plus -1. So, and over D, which D is 3. So you do 4 plus -1, you get 3. Put it over 3. 3 divided by 3 is 1. Okay, so just put them in to your, just figure out, write all of these out. I would do that first. And then just go over and do them with your calculators. Okay. Critical thinking. The value of the value of a is the value of 3x squared minus 4x minus 5 when x equals -2. Find the value of 3a minus 4. So the value of a, you are figuring out the value of a right here. So x equals -2. So we do 3 times, what's the -2 caret button 2, and you get x would equal positive 4. Then we would do minus 4x. So we figure out what 4x is. 4 times negative 2 would be negative 8. So we would be minusing negative 8. Then we would go minus 5. So we go 3 times 3 times 4, 4, do that. Do this one right here, 3 times 4. Then we would do minus negative 8 minus 5. And you should get your answer. I want you guys to rewatch this as many times as necessary. We can also slow down a little bit, do this a little slower. Hey, guess what? We're on to section 4.2. So we will do that, save that for tomorrow's lesson. Judy, make sure to text me and tell me if we need to go over this lesson a little bit more. All you're doing, though, guys, for this is substituting numbers in for your variables. So like number 57, it's 3x. Well, what does x equal? X equals 2. So it's 3 to the power of 2 minus, and it's or it would be 3 caret button 2 for the first part minus x to the third minus 2 caret button 3 equals. Then you're just adding the 3 squared, which would be 9, minus 8, which would be 1. Because 2 to the third power, or 2 caret button 3, is 8. So I want you guys to work on this hard. I am going to stop. Oops. I am going to stop recording this right now, and I'm going to prepare another video for you guys. We will do the starting of a platformer game. Judy, do not let them work on their video games until they have finished all of this. And when you guys finish all of this, you get the reward of programming a video game, which I am about to go to. So, I will talk to you later.